This is Programming Chapter 6, Part 2. We're going to look at bubble sort. It has the same efficiency as insertion sort. And it's also an in-place sort. It also uses 2 loops. We're learning it just because we're learning a different algorithm. In practice, a bubble sort is a little less efficient than insertion sort. However, if you use a swap flag, it could be a little bit quicker. And again, we're going to work off the same list. And we're going to loop from the beginning to the end. And we're going to loop the same amount of times downwards. We start at 0. We check to see if this element is smaller than this element. It is. We move on. We check to see if this element is smaller than this element. It's not. So we swap it. The -3 goes here. The 16 comes up here. Again, we check this element with this element. Is 16 less than 4? No, so we move it down. So 16 gets promoted again. Is 16 less than 11? No. So 11 gets moved down. We swap. And finally, we check to see if 16 is less than 4. No, it's not. We copy down and we promote it. So now our array looks like this. And it's called the bubble sort because the biggest value moves to the top. Bubbles rise. So the biggest value moves to the top. We could do a descending sort as well, but right now we're going to concentrate on ascending sorts. Okay, start at index 0 again. Is 8 less than 3? No. So we move the 3 up. 8 gets promoted. Is 8 less than 4? No. We move the 4 down. 8 gets promoted again. Is 8 less than 11? No. So it stays in place. We move to the next 2 elements. Is 11 less than 4? No, so we move that one. 11 gets moved up. And we can stop there. We know 16 is the biggest element, so we just stop at 1 less than the number of iterations. 1 less than number of iterations. Okay, this time we're going to stop here. Is -3 less than 4? Yes. Is 4 less than 8? Yes. Is 8 less than 4? No. We move the 4 down, we promote the 8 up, and we're done. And now we start from here. We set the no swap flag each time to false. And in the first iteration, we did a swap. We set it to true. If it's true, we do another iteration. Here, we did a swap again. So it's true, so we're down here. Now we check. We only need to go to there. Is -3 less than 4? Yes. Is 4 less than or equal to 4? Yes. So we don't do any swapping. We can terminate early. Okay? If you didn't terminate early, then you do one more. You check to see if -3 is less than 4. So we save ourselves 1 iteration. For larger lists, you would be saving possibly more than 1 iteration. Okay, so to implement this algorithm, you need to use nested loops. We did that before. We used a for loop and a while loop. This time, you'll probably want to use 2 for loops because you know the exact value that you want to iterate to. Be careful with your counting. Here, there's 6 items. We needed to do 1, 2, 3, 4, 5 comparisons. And the next time we do 1, 2, 3, 4 comparisons. So your n was 6. This loop was 5. This loop is 4, 3, 2, 1. And you can't do 0 comparisons, so you have to stop at 1 comparison. It's good to write things out before you start coding, just to make sure that you set your variables properly. That's about all the hints I'm going to give you. And I'm being vague, but following how we went through the sorts and compares should help you with the numbers that you're supposed to get. So be careful about how you count and print out your results with each line, just like we did here. And we're going to assign a bonus mark for using the swap flag. And exercise 6.4, you're going to pick either insertion sort or bubble sort. And if you need to, look back at exercise 5.2 to learn how to generate random numbers. You're going to generate 40 random numbers between 0 and 199. Then you're going to sort the list. And you can decide how you want your printout to look. And that completes part 2 of chapter 6. When you're done, please proceed with part 3.